Hi, in this video we'll solve the question longest turbulent subarray. Okay, so what is given in the question? We are given an array. We have to return the length of the maximum turbulent subarray. So what is a turbulent subarray? Basically, a subarray is turbulent if the comparison sign flips between the two adjacent pair of elements. Let's suppose this is the given array. So the signs, the longest subarray in which we have the adjacent element, the sign of the adjacent element flips. So here we have greater than sign. For the next adjacent pair of elements we have lesser than sign. For next adjacent pair of elements we have greater than sign. For next we have smaller than sign. So we have 5 elements in this array. Let me take example of this array, try to explain it more clear. We have 9, 4, 2, 10, 7, 8, 8, 1, 9. So if we take the first element into consideration, these two elements under consideration, what signs we have? This is greater than 4, this is greater than 2, this is smaller than 10, 10 is greater than 7, 7 is smaller than 8, 8 is equals to 8, 8 is greater than 1, and 1 is smaller than 9. So what we want a longest subarray in which the adjacent pair of elements have opposite sign. That is, if this pair of elements has greater than sign, so this should have a smaller than sign. Okay, for this we want the longest subarray under this consideration. Okay, so what we can see, if we analyze this pair, we have 9 greater than 4. Okay, so if we want this to be considered, we would have a smaller than sign, but it is not possible. So our subarray size, if we consider this pair, is 2 for these two elements. Now if we start considering with this pair of elements, we have 4 greater than 2. So it is correct. Then we have 2 smaller than 10. So the condition also satisfied because we have the sign, opposite signs for the adjacent pair of elements. So for the next element we again have the flip of sign. So for the next element we again have the flip of sign. So if we consider the longest, so it would be the longest until this point. So we have longest of size 5. So 1, 2, 3, 4, 5. So for the next pair, if the two adjacent elements are equal, we ignore this condition. Okay, we just want greater than or equals to sign. Okay, so we start considering from this element. We have 8 greater than 1, so it's okay. We consider the next pair. 1 is smaller than 9, so the operator signs get reversed, so we can consider this. So our answer for this condition is 3, but we have to consider the maximum one. So the maximum one between 3 and 5 is 5, so we'll return the output as 5. So how would we approach this question? This is the explanation, whole explanation of the question. Now we look at the intuition behind to solve this question. Okay, now if we analyze this particular test case, so what we can see once again, what we can see, when the sign flip occurs, there should be a mountain or a valley condition. So what is meant by mountain or valley condition? Mountain condition is when the adjacent elements are smaller than the elements under consideration. Okay, if we are considering this particular element, so the adjacent two elements should be smaller than this. Okay, what is the valley condition? If we considering our element and the adjacent elements are greater than it. Okay, so this is a valley condition, this is a mountain condition, and in these two conditions the turbulence will happen. So if we draw the representation, graphical representation of this particular subarray, how we can draw it? We have let me draw this one. Okay, and I will draw it. So we have 9 here. Let's suppose we have 9 here, we have 4 here, we have 2 here, we have 10 here, we have 7 here, we have 8 here, then again we have 8 here, then we have 1 here, then we have 9 here. Okay, so this is the representation. So what we have to consider, we have to only consider the continuous valley and mountain form. Okay, we are starting at first index, then our checking will start from this particular index, because if we consider this index, we cannot analyze if the particular element is a valley or a mountain, because it is a single element, it only has one element on its right. Okay, so we'll start considering from this element. Okay, we start considering, let's suppose I mark it with blue color, let me mark it with green. So we are considering from this. So is this a valley or a mountain? Is this a valley or a mountain? It is not a valley or a mountain. So we are only considering this part because we are only getting one sign. So our answer would be, if we mark it as starting and this as end, we get our answer as start minus end plus 1. Okay, and we analyze our answer. If we analyze this as the 0th index and this as the 1 index, so we get, sorry, end minus start plus 1. So we have 1 minus 0 plus 1, 2 as our answer for this particular case. Okay, we have not find a valley or a mountain, but we find just a single sign. So for a single sign, we are having only the two elements. So our current value, the current values is 2. Now we start checking for the next element. We will start checking. Okay, now we will move our start here and our end will be here. Now we consider it if it is a valley or a mountain. It is a mountain? No, it is not a mountain, it is a valley, but it is a valid condition. Okay, so when there is a valley or a mountain, we iterate to the next element. Okay, move to the next element, so our end will reach here. If the particular element is a mountain or a valley, it is a mountain, and whenever we found a mountain or a valley, we move to the next element. Okay, is this particular element a mountain or valley? Yes, it is a valley. We iterate over to the next element. Is this particular element a mountain or a valley? It is not a mountain or valley. So whenever our condition become incorrect, we calculate our answer. Okay, we calculate our answer as end minus start plus 1. So for this case, we have end here at so we index it 0, 1, 2, 3, 4, 5. Fifth index, we are at fifth index. 5 minus 1 plus 1. So we have our answer as 5. So the output, the maximum length will now be will become 5. So our start will come here. Our start will come here, and end will start from this position. But whenever we are considering if our adjacent elements are equal, we ignore this part. So we'll move our start to the next position. So these two elements are not equal. Okay, we make it as start and ending from the next position. Is this particular element a mountain or a valley? It is a mountain. So we move to the next element. We iterate to the next element. Is this a mountain or a valley? So it is our last element. So we consider it as the mountain. Okay. Whenever we have the last element, we consider it as a mountain. Okay. So we find our answer as, so we have 6, 7, 8. 8 minus 6 plus 1. We have 3 as our output for this particular case. So what is our maximum answer? It is currently 5, so we cannot update it. So this is the particular approach to solve the problem. Let us analyze one more test case. Okay, we analyze one more test case. We have 4, 8, 12, 16. Okay, we have 4, 8, 12 and 16. So let me draw a graphical representation of it. Okay, we have 4, 8, 12 and 16. 4, 8, 12 and 16. So our search starts from here. Start will be this, end will be this. So is this element a mountain or a valley? It is neither a mountain nor a valley. So we'll calculate our answer as end minus start plus 1. So we have 0, 1, 2, 3. So we have 1 minus 0 plus 1, 2 as our answer. Current answer is current maximum subarray length is 2. So we'll move to the next element, make the current end as the new start, and end would be start plus 1. Is this the current element a mountain or a valley? It is neither a mountain nor a valley. So we again calculate our answer E minus using this formula. We get 2 minus 1 plus 1, 2 as our answer. So we make our current end as start and make the end as start plus 1. So for this position, is this a mountain or a valley? So this is a condition. We consider it, because it is a last element, we consider it as the mountain condition. Okay, so we have 3 minus 2 plus 1 as our current output. So we have our output as 2. So we cannot update our maximum answer. Our current maximum answer will remain 2. So this is the particular approach to solve the problem. Now I will show you the code. Okay, I will write the code for it. So what we are considering, first of all, for a mountain or a valley, what is the condition of mountain or a valley? So we write a function is mountain or valley. So this is a function that's check for a particular index if it is a mountain or a valley. Okay, so it would be a Boolean function. So we have a particular index. So if the particular index we are taking into consideration is greater than its previous element and is also greater than its next element, it is a mountain condition. Okay, this particular condition is a mountain condition. Okay, or if we don't have a mountain condition, we can have a valley condition. So for a particular index, we also check for a valley condition. If the particular element we are considering is less than the previous element and it is less than the next element, then we return, then in these two conditions, this is a valid condition, then in these two conditions we'll return true, else we'll return false. So this is our mountain and valley check function. Now what we'll do, we'll write a function using two pointer approach. We are using two pointer approach here. Our at the starting, our start would be at 0. Okay, our start would be at 0, and we'll use a while loop until our start plus 1 remains less than n. Okay, we also need the end variable. We also need a variable that is used to contain our answer. We can name it as answer. Okay, ns, and it would be initialized to 1 because the minimum subarray length that we can consider, it can be 1. Okay, so now, so we explicitly have to check a condition. Okay, what condition we have to check? If a current element is equals to the next element. Okay, that's why we are using s plus 1. So if our current element is equals to the next element, so we are ignoring this part. So what we'll do, we just move to the next element and continue. So we are ignoring this part. Okay, ignoring the part where whenever the two adjacent elements become equal. Okay, and when they don't become equal, we initialize our end with s plus 1. Okay, this is a basic condition, and we are also using a inner loop, but our time complexity will remain order of n. I will tell you why. Okay, now I have e, and we check a condition until e plus 1 is less than n, and if the particular index is a mountain or a valley. If the particular index a mountain or a valley, then what we can do, we can move to the next element because our subarray size will increase when we increase e. Okay, our subarray size will increase. Okay, whenever we found a mountain or a valley, we move to the next element, and whenever we found a neglecting condition, then what we'll do, we'll found our answer. Okay, found our answer as e minus s plus 1, and the maximum between what we are considering as our answer variable, it shouldn't be mx, it should be answer, and we are considering max among them. Okay, it would be updated as our answer, and we would update start as e. It would be our next step. Okay, and at the end we'll return after the loop. So this is where this loop will end, and after the loop we'll return our answer. Okay, so now I will show you the whole code. So this is the whole code. Now let me show you the dry run over the code. We have a test case as this 9.4 we consider here. Yes, we consider that. We have 9, 4, 2, 10, 7, 8, 8, 1, 9. Okay, we analyze it through the code we have written. So at the starting, what we have a start as 0 and end as start as 0 and end as 0, and our answer as 1. Okay, this is given in the code. So our start would be here, end would be here. Okay, so we'll check while s plus 1 is less than n. So what is n in the given condition? So what is the value of n? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So the value of n is 9. Okay, 9. Until this condition satisfy, we look for a ignorance condition if the current element and the next element, the two adjacent elements are equal, then we just move to the next element and continue. Okay, we'll check this thing. So this is not happening, then we'll update our end will with s plus 1. So our end will become s plus 1. So we'll check while e plus 1 less than n, e plus 1 less than n, and is mountain or valley. So this is the function we have written. We pass our array and a particular index e. Okay, now if this condition satisfy, we increment our e. So for this element we'll check the mountain or valley condition. So it does not satisfy mountain or valley condition, so we'll move out of this loop and we'll calculate our answer. We'll get our answer as e minus s plus 1, and among these two we update our answer from the maximum among these two. So our answer will be 2. Okay, we'll update it as x. So our answer will be 2. So after this what we are doing, we are updating s with e. So we are just doing a single traversal of the array. Okay, single traversal of the array. So our start will become this and end will become this. Now for this particular element we would check if this is a mountain or valley condition. Yes, it is. We move to the next element. Is this particular element? Yes, it is a mountain. Is this particular element? Yes, it is a valley. Is this particular element? It does not satisfy the condition of a mountain or a valley. So we have our e index here. So we'll find our answer, update our max answer. We'll get our max answer as 5. We'll make our start here and end here. So we cannot update end here because these both are equal. So we ignore this part and move s one position, move s by 1 position. Now s will be here, e will be here. It is a valley condition. We move e to the next position. So it is our last element. So it does not. We make it as a mountain. So what we'll do, we'll update our answer as this. So our current answer will be 3, our maximum answer is 5, so we cannot update it. So this approach requires a time complexity of order of n. Okay, order of n. So, and it does not require a space complexity. Space complexity is order. So this is a 2-pointer approach to solve the problem longest turbulent subarray. Okay, bye.